Thank you very much. Our next presenter is Professor Abbas Aminmansour, and he's an associate professor at the University of Illinois at Urbana-Champaign, USA. His presentation will focus on tall buildings and sustainability and integrated approach, and it will offer an overview of the numerous characteristics of tall buildings that may contribute to more sustainable design. Professor Aminmansour is an associate professor in the Structures Program, School of Architecture, and at the University of Illinois. And his areas of research interest include integrated design, construction, and operation of tall buildings, as well as sustainable design. Welcome to the floor. And,
Thank you. Thank you very much. I'm delighted to have the opportunity, and thank you for coming. We'll put this on fast forward, and we'll skip some of the slides that I have so that hopefully we'll have some time for discussion. Let me just explain the purpose of this presentation. I'd like to present sustainability in a very different way, in a hopefully unconventional, thought-provoking way. I'm not going to discuss whether tall buildings are sustainable or not. I think that the term is absolute, and it's a little not perhaps the most appropriate way to apply to tall buildings. I think it's more appropriate to talk about sustainability impact of tall buildings, because the impact tall buildings have in terms of sustainability goes far beyond their own limits. And hopefully we'll look at sustainability a little bit differently by the end. We've all seen different definitions of what sustainability is. Just a couple of phrases that I'd like to emphasize that you see in this particular version of what sustainable development is. Talks about improving lifestyle, so we're not talking about sacrificing quality of life, feeling of well-being, and also talks about preserving our natural resources and ecosystems. Those are all terminologies that we're very familiar with. One of the perceptions that exists among many people, certainly the public, is that when we talk about sustainable buildings, we're talking about efficient HVAC system, maybe going a little further, including lighting and perhaps even the curtain wall. Obviously, this does not give a complete picture of what sustainable buildings are or what sustainability is all about. As far as tall buildings are concerned, there are a number of features or characteristics of tall buildings that affect the sustainability impact of the building. Architectural design, structural design, MEP design, construction, building operation, urban issues, and deconstruction. Some of these are more obvious than others. I'm not going to talk about MEP because we've all heard about that in many different presentations. That's probably one aspect of sustainability that a lot of people can relate to more directly. I do want to point out building operation. We don't design and build buildings just for the sake of having designed and built a building. The purpose is for the building to go into operation and serve its purpose in a very economical and efficient way. So operation is very, very key in my view in terms of when we talk about sustainability. I'll talk about some of these other specific items a little bit more later on. Three aspects of sustainability that oftentimes you read in the literature. One is environmental aspect, one is economic, and also quality of life. The reason I mention these is because this would hopefully help us put things in a little bit better perspective when we talk about some of the other issues that will come up in a few moments. How do we measure sustainability right now? Well, the most common methods that we use are things like energy consumption. We find out how much energy a building consumes in terms of per square foot, per unit time, whatever that time period is. And we oftentimes compare that to other buildings, and we say this building is more or less efficient than another. We also talk about material use, partly because of the use of the limited resources that we have, and also because of the embodied energy and carbon content and whatnot. And of course, sometimes people go beyond that, and they also look at life cycle assessment, which is very appropriate in terms of looking at sustainability. Those are all very good measures. They're very appropriate. If we were to evaluate the effectiveness of a design, we need to have some measuring sticks so that we can measure them. Those are all very appropriate, but perhaps not very complete. We do also have organizations in the US and other countries that I guess, help us, or whatever you want to call it, rank buildings in terms of their sustainability qualities. They have certain criteria. I personally tend to not agree with some of their criteria, and I hope some of you don't either. This is one particular subject that I can talk about a lot. I have a lot of things to say, but you know, like I said, we do need to have measuring sticks so that we can compare. But on the other hand, I think the criteria needs to be a little more refined and more appropriate. We've also seen in some of these organizations significantly changing their criteria, which indicates that perhaps the criteria we were using before were not quite on track, and suddenly there's a big change. I'm very concerned about the bean counting impact of these rankings, because we often talk about what do we need to do to get this output, to get the silver rating or whatever it is. What do we need to do to get more points, to get towards that point? That's very scary. That tends to lead us in a wrong direction, in my view. Professionals should be focusing on delivering the best design that they can rather than counting beans and trying to work towards an objective that may not really have a very meaningful value anyways. I will give you an example a little bit later on. I gave a presentation at a conference a couple of years ago, and I gave an example of, which I will share with you a little bit later, how a structural design could have a considerable impact on sustainability of a building. And during the question and answer session, there was a question, do you get points for that? I think it's a very unfortunate way of looking at things. Again, as I mentioned earlier, and I will reiterate this later, the idea should be to deliver the best, highest performing building. Forget these points and all this. There are also some discussions in some countries about having, similar to what you see on your appliances, energy guide or stickers that will say how effective this building is. And again, those measures may be accurate within a certain context, but they should not be viewed as an overall appropriate evaluation of a building. Let me talk a little bit about the characteristics of tall buildings so that, again, we put things in better perspective. There is a high level of expertise and skills that go into development and design and development of tall buildings. Not everybody designs and builds tall buildings. You have to be highly skilled, highly knowledgeable, very experienced. You need to know what you're talking about. This conference, obviously, we've heard a lot of very highly regarded professionals who've designed and built tall buildings, very, very skilled people. What that means is that you will have buildings that are very efficient, very well designed, and oftentimes they apply the state-of-the-art in whatever field. They're also very safe buildings, as opposed to what some people feel. Unfortunately, when there's an unfortunate incident such as 9/11, suddenly people start questioning the safety of the buildings as well. In fact, in my view, tall buildings are excellent shelters for certain situations. Imagine, there are certain natural disasters that cannot be predicted, such as earthquakes, but winds and things like typhoons, tsunamis, maybe tall buildings can serve as shelters. There may be water damage, but the buildings will certainly serve as very appropriate shelters. Tall buildings also have lower surface exposure, and whether you look at it in terms of surface to floor area or volume, and that means that they also they certainly have higher qualities in terms of energy efficiency from that point of view, strictly speaking. Other characteristics of tall buildings, urban issues. Tall buildings are very effective in terms of using land and developing high-density populations. They are tremendously helpful in terms of more efficient infrastructure. Imagine, for example, if a building has 500 units, residential units, if those units were to be built in the suburbs. It takes up a lot of land. It requires significant infrastructure, whether to deliver utilities, water, electricity, gas, sewage, and all this. Significant amount of requirements in those regards, which will certainly affect the sustainability of the entire community. That's why I said tall buildings have sustainability impact that are very important. Imagine all those people who would live in the suburbs otherwise, commuting back and to work every time. They spend a lot of time on roads. There's a lot of fuel consumption. There's a lot of erosion of roads and bridges that need to be replaced or maintained. Again, those are all impacts on sustainability that tall buildings could address. And there are, of course, some social implications. I'll come back to this a little bit later on. Other characteristics of tall buildings, again, and some of these they could be viewed as positive or not so positive, but I want to share some of these points so that we can come back and draw some conclusions. Certainly, tall buildings consume more material to build, mostly structural material. There is a premium for height. We all know that, and we can't until we find a situation where we can stop wind and prevent earthquakes. We're going to have to pay a premium for design of tall buildings in terms of structure and material use. Also, they have a high ratio of translucent to wall area. That's part of their architecture. It's very appropriate in my view. But that means there will be more daylighting, beautiful, spectacular view, but there also may tend to be more energy, heat gain and heat loss, which may be the other side of the equation. They consume more energy to build because of the height, because of their concentration, delivering material to high heights. To build buildings that are spread on ground is one thing, but to concentrate all of that in one small area, that requires a different level of energy. And of course, they take longer to build because of the reasons that I just mentioned. Now, so let's talk a little bit about what are some of the considerations that we can have that would lead to overall sustainability impact of tall buildings. Designing for wind is one of the key issues, of course, because lateral load resisting systems are a very prominent part of tall buildings. Building form, we've heard these things many times at this conference and in other venues. Form and shape, and some of the characteristics such as aspect ratio, surface to floor ratio, and those aspects will certainly affect the impact of wind on the structure and the loads that it has to resist. Building orientation, siting the building on the site itself. You could sometimes adjust the siting, the angle of the building, the orientation of the building, and significantly reduce the wind forces that the building will experience. The bottom line is that you and I cannot change the wind speed. That's nature. But we can significantly reduce the forces that a building will experience, and therefore reduce the amount of structure, reduce the amount of load that it uses. And sometimes that actually less structure means more available space in the building, which also will have an impact on the sustainability effects of the building. Sky bridges, again, could be very effective in reducing the areas that are taken up by egress and so forth. Structural considerations, use of the most effective structural systems, less material, less building, less weight, therefore even less structure, less embodied energy. There are a number of structural types that are used these days that make design of tall buildings a lot more effective. Fazlur Khan was a genius. He developed those wonderful structural systems that many people use for quite a long time in designing tall buildings. But as we heard this morning, things have changed, and there are things may need to be done a little differently. Using dampers, a lot of engineers have been resistant to using dampers in the past, but by using mass dampers and viscous dampers, you can considerably reduce the amount of structure, amount of material that is used, and embodied energy. They also, at the same time, you can enhance the performance of the building. Use of other innovations that we've heard, some of the innovations that we've heard throughout this conference, using of rocking bases and dampers to reduce the forces on this structure. The bottom line, the key is that we want to look at the sustainability impact of building tall buildings in a very holistic way. Let me give you a very quick example. Imagine you have a tall building. The numbers I'm about to give you are not very realistic, but they may make the math a little simpler to follow. Imagine you have a building that has a footprint, which is a square, 250 feet in each direction, so that's a total perimeter of 1,000 feet. If you make your floor sandwich 3 inches shallower, you may use more material, you may not have the most effective structural floor system, but if you make the floor sandwich 3 inches shallower, in a 60-story building, you save 180 inches, which is about 15 feet, Imagine that's 1,000 feet perimeter times 15 feet. That's 15,000 feet of square feet of less curtain wall alone. Multiply that by whatever the cost is. There's significant cost savings in the curtain wall alone. In addition to that, you have less height, therefore less wind load, less forces, less structure needed, less space to heat and cool during the life of the structure will have a significant effect on the life cycle performance of the building. So there are some simple things that can be done that may seem inappropriate at one point, but certainly will have a longer impact. Elevator systems, as we all know, elevators are very, very key in design of tall buildings. Obviously, you need to have enough of them so that the occupants are very comfortable and meet their expectations. You don't want to spend $15 million on a penthouse and then have to wait 10 minutes for an elevator to come. So there needs to be some rationale there. But they do take up space. They use energy. Some of the things that we can do is to use them for other purposes, using them for evacuation if permitted by code, and if it's appropriate, that would potentially reduce the need for other means of egress. Optimize use of elevators through some of the technologies that are available these days. If you can take away 1 square foot out of an elevator shaft and make that usable space, that 1 square foot can generate considerable revenues throughout the life of the building, and therefore make the building actually more sustainable, because with the same volume of building, the same mechanical systems or whatever, you will end up having more of it usable space. Some of the issues that, let's see here, let me actually skip this one since time is short. I do want to talk a little bit about deconstruction and its relationship to sustainability. The Earth, according to Wikipedia, and we all know how credible that is about 4.54 billion years old. Okay, I don't know how accurate that number is, but it is very, very old. It's been around for a very long time. We hope that it will be around for a very long time too. But do our buildings also last that long, or do we want them to last? Is that 1 minute signal?
Yeah.
2 minutes? Thank you. Do our buildings last that long? At some point, we have to deconstruct these buildings. And we haven't faced that problem yet, unfortunately. That may have been misleading us. We do need to think about it, and this is something that needs to be done during the design stage. Deconstruction of a building can have significant impact in terms of energy consumption, waste that it produces, in terms of economy, quality of life, and like I said, material selection could possibly make a big difference if it's taken into consideration during design time. If we don't do this, at some point we'll have to start dealing with this, and we'll find out that our buildings may have been more so-called sustainable during their life, but at the end, they're quite the opposite. So, starting to summarize some of the strategies that you want to use, one is obvious for more sustainable buildings or more sustainability impact. One is obviously you want to reduce the demand for resources and reduce the amount of adverse effects. So, for example, if we're talking about lighting, you want to provide the same amount of lighting that is necessary, but on the other hand, you want to provide that lighting through other means, maybe daylighting or whatever, so that we need to use less energy, more efficient fixtures, and alternative sources of energy. Let me just do this last word. In my view, despite their so-called higher relative costs of construction and consumption of energy and whatnot, if you look at tall buildings in a holistic way, they have a very positive sustainability impact. They are very efficient. They contribute significantly to sustainability of our limited resources. They're very economical, and they certainly improve the quality of life. Thank you very much.